Hi everyone, this video is for part 2 or day 2 of radian measure, and we're going to talk a little bit about the unit circle. So you should have a handout in front of you that goes along with the video. It also does match, partly at least, the other unit circle that we started filling out in class a few days ago. Okay, so here we go. So yesterday, or on to yesterday's video, I guess, you learned how to change from degrees to radians and how to change from radians to degrees, and also how to find arc length. So we're just going to go do a quick recap of that. So when we talk about changing from degrees to radians, the N in this case stands for the degrees of the angle you're talking about. So you're trying to get rid of the degrees, which means you need to add a pi, if you will, into the problem. So for instance, if I had an angle that was 40 degrees, then I would find the radian measure by multiplying 40 by pi over 180. So then this measure would be equal to, let's see, we're just going to reduce this to 2. So 4 and 18 reduced to 2 and 9. So this reduces to 2 pi over 9. So 2 pi over 9 radians. Now, if you have something that's given to you in radians instead, then in this case, the N would stand for the angle in radians. And a lot of times it'll be in pi form already, but sometimes it'll just be a number or a decimal, and that's fine too. So let's say you have an angle that is, let's say 3 pi over 5, okay? So if that's your angle in radians, then you are going to multiply that 3 pi over 5 by 180 over pi. Okay, so I'm going to reduce this. Just cancel the pi's. 180 divided by 5 is, didn't bring my calculator with me when I came over here to sit, so I should have done that. You'd think I would know. But 180 divided by 5 is 36. Had to think carefully about that. So now I'm going to multiply 36 times 3 to get the final answer in degrees. So 36 times 3 is 108. So that becomes 108 degrees. All right, you also learn about arc length, and I just wanted to remind you that when you're working with this formula for arc length, the R stands for the radius of the circle you're working with. The theta stands for the angle, but the angle is in radians. So you need to make sure if it's not in radians, you change it to radians first. And then the S stands for arc length, but it really means like a portion of the circumference of the circle. So portion of the circumference. I need a new tip on my stylus here. Okay, so let's say I told you that there was a circle that had a central angle of 50 degrees and a radius of 8 inches. So you could find that arc length, so that's this right here. You would first have to change that theta, that angle of 50 degrees, into a theta that's in radians. So you would do the formula from above. You would do, two above, excuse me. You would do R is equal to pi over 180 times 50. And you're going to do some reducing. Okay, so now this doesn't 5 and 18 don't reduce. So I just get this radian measure to be 5 pi over 18. I don't know if you can hear my cat meowing again. Sorry. And now I'm going to find the arc length by taking the radius of 8, multiplying by 5 pi over 18. So we're going to do, however you want to reduce this. I think I'm going to reduce this first. So I'm going to do, make a different color here. 18 and 8, so this becomes a 4, and this becomes a 9. And I feel like this is the same problem we did yesterday. I just accidentally made up here, but that's okay. We get 20 pi over 9 is the length of arc in inches. Okay. Okay, so that's a quick recap. And then now we're going to move on to talking about all of the angles on the unit circle. So you've already done or filled in parts of this already. So I'm just going to fill in a little bit, like refill it a little bit. If you haven't filled this stuff in, now is the time. Okay, so I'm going to try and make it fit the best I can on my little computer screen here. Okay, so we started off when we were filling it in by filling in the quadrantal angles, which were the ones that were on the axes. So like this is 0 degrees, this is 90, this is 180, this is 270. And if we come all the way back around, we could also say that this is 360 degrees. Well, we can now fill those in with a radian measure if you didn't already do this. So we know in radians, this would be 0 in this spot, still 0 radians, but it's also 2 pi radians if you go all the way around the circle. And then we know that over at the 180 side, well, that's half of the circle, so that's half of 2 pi, which is pi. And then up at the top, this is half of pi, because it's half of a circle, so this is pi halves. And now we're going to talk about how to quickly get all the measures using this kind of cutting things in halves and fourths and such. So this is 1 pi over 2. This is like 2 pi over 2, because it's pi. That means down here, oops, I wrote that in the wrong spot. This would then be 3 pi over 2. And then this is 2 pi, or even think of it as 4 pi over 2. We can do this all like with common denominators. Okay, and then we also started filling in the angles in degrees in the other spots on the circle. And we did this using reference angles to the first quadrant. We didn't get very far with this. That was the day that I think I was absent, right? We didn't get through all of it, and I was absent the next day. So hopefully this will make sense as I go over here. So this is a 30-degree angle, and this is 45, and this is 60. So we kind of talked about those a little bit. Now, all of the angles around the circle are all going to be able to have these three as the reference angles. And so there's going to be all of this symmetry going on in the picture. So like this angle right here, well, that's reference angle of 30 over there. They're at the same distance off of the x-axis. So what that means is that this angle here is 30 above 180, which means I can just do 180 minus 30, and this is 150. And the same thing happens down in quadrant 3. So this angle here is the same distance from the x-axis as these two are here, and they're both 30 away. So I'm going to take this 30 and add it onto 180 and get to 210 in this spot right here. And then going this direction down here, we've got the same situation. So now I've got, we're 30 away from the x-axis, but it's like I went all the way around and stopped 30 away. So I'm going to do 360 minus 30 to get 330. Oops, can't read that. To get 330 in this spot. And we also spent some time filling in the coordinates of these angles in the first quadrant and on the quadrantal angles as well. So we filled in that this over here, so keeping in mind that this is like the x-axis and this is the y-axis. Okay, so over here we went to the right and didn't go up, so that was 1, 0. And then at the top here, this is then 0, 1, because I didn't go left or right, I just went up. And then here I'm going left 1, but not up or down. And then down below here, we went down, but not left or right. So this is 0, 1. Sorry, 0, negative 1. All of these coordinates can be found in the same way. And we did do a little bit of this, so hopefully this will make sense. So we're using what we did with our 30, 60, 90, and 45, 45, 90 angles to make this happen. So the 30-degree angle at the spot here. So again, think of making this right triangle out of this. This 30-degree angle has an x value of root 3 over 2 and a y value of a half. That means all of the all of the coordinates for each of the quadrants have the same numbers, just different signs. So like in quadrant 1, your x is positive and your y is positive. But in quadrant 2, your x is negative and your y is positive. So that means I'm going to use the same x value but make it negative. And my y value will stay the same. And then down in quadrant 3, both your x and your y are negative. So I'm going to take the x and the y values and make them negative, but use the same values. So negative root 3 over 2, comma, negative a half. And then over in quadrant 4, well, now the x is positive and the y is negative. So same numbers, make the x stay positive and the y becomes negative. Now this all relates because these angles can also be found to have radian measure. So we're going to actually fill in the radian measures in these spots. Now you're welcome to, every single time you have an angle that you don't know, to actually find the radian measure. However, like the calculate it. However, it will be easier if you start to slowly memorize them. So I'm going to show you some shortcuts. So this angle, I'm not going to calculate it. I'm just going to tell you is pi sixths. Okay, pi over 6. All of the 30-degree angles will all be something related to 6 in the denominator. And you can do this in the same way as we did with the degrees. So if this angle is the same distance, it's pi over 6 away from the x-axis, just like this one was pi over 6 away, then I'm going to take pi and subtract pi sixths. So I'm going to take 6 pi over 6 and subtract pi over 6. And this spot becomes 5 pi over 6. Now I'm going to add pi over 6, and this becomes 7 pi over 6. And now I'm going to subtract pi over 6 from 2 pi. So subtract pi over 6 from 12 pi over 6, that would be the common denominator, and this becomes 11 pi over 6. Okay, now a couple of shortcuts. These two things add to 2 pi, and these two things add to 2 pi. Just one way to think of it, but these 4 are all pi sixths. Okay, so now I'm going to go through the rest of them a little bit faster. So the 45 degree angle in the middle there, all of them in the same spots in the middle are all 45 away from the axes. So I can find them by adding or subtracting 45, depending on which quadrant we're in. So if I take 150 minus 45, this angle is 135. And if I take 180 plus 45, this angle is 225. And if I take 360 minus 45, I get 315. So those are our 45 degree angles. Each of the 45 degree angles will all have the same x and y values, just different signs. So the 45, 45, 90 right triangles have root 2 over 2 and root 2 over 2 as both their x and their y. So then you just have to figure out, well, what quadrant is it in? Is it positive or negative? So quadrant 2, we go negative root 2 over 2, positive root 2 over 2. Down in quadrant 3, they're both negative, so negative root 2 over 2, negative root 2 over 2. Sorry, my stuff is starting to overlap in this screen here. And then in quadrant 4, it'll be positive x, so positive root 2 over 2, negative y, negative root 2 over 2. And all of the radian measures will have the same denominator. So in quadrant 1, the 45 degree angle turns out to be pi over 4. And then you're pi over 4 away from pi, so you're subtracting. So that gives you, I don't like that color, I'm going to change it. That gives you, eeny, meeny, miny, mo. Let's do this one. This is 3 pi over 4. This is 5 pi over 4. This is 7 pi over 4. And then the last angle that we're going to talk about is the 60-degree angle. And the 60-degree angle works the same way. So it's 60 away from the x-axis. So you're going to do 180 minus 60 to get this to be 120. And then you're going to do 180 plus 60, and that is 240. And then you're going to, oops, put that in the wrong spot. And then we're going to do 360 minus 60, and that's 300. So those are the degrees. The coordinates then are the opposite of the 30-degree ones. So they're the opposite of this. So we just switch them. So this is going to be 1/2 root 3 over 2. Switch the x and the y around. Get that line to show up. There we go. And then we just switch the signs. All of the coordinates are now the same, but we switch the signs. So this becomes -1/2 root 3 over 2. And this is -1/2 negative root 3 over 2. And this is +1/2 negative root 3 over 2. And then finally, we can get the radian measures by doing the same thing. So I'll just tell you, you could calculate it, but I'll tell you that the radian measure of 60 is pi-thirds. And so then all of the 60s are pi-thirds away from their x-axis. So pi minus pi-thirds is 2 pi-thirds for here. And pi plus pi-thirds is 4 pi-thirds for here. And 2 pi minus pi-thirds is 5 pi-thirds. Okay, there's a lot of scribbling on that screen, so I'll have a little bit of a nicer filled in one for the next stuff what we're going to do. So the reason we do this, the reason we fill this in is it makes it faster for us to calculate trig values of angles that are on the unit circle, whether they're in degrees or radians. And so we're going to start using a little bit more radians for practice purpose, okay? So we've got a few practice problems here. Oh, actually, this is just matching. We're going to do this first. I was going to have you guys do it together in class, but I'll just do this since I'm obviously not there. So the first row is quadrant 1 angles. I don't have any quadrantal ones here. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So I'm just going to drag and drop the angles, and you want to look for the smallest one first. So the smallest is when they're the smallest numerator and the largest denominator, right? So 30 is pi-sixths, 45 is pi-fourths, and 60 is pi-thirds. Okay, so now all of these are the 60s, all of these are the 45s, and all of these are the, I said that wrong. That's not true. These are all the 45s, but these are switched because it's actually going in order. So these are not going to be quite the same thing. So this is a 30 and this is a 30. So I think I'm going to move them around so that we can match them up. Okay. So 135 is the 45-degree angle in quadrant 2. So that's this angle. We'll do all the 45s first. 225 is in quadrant 3, so it has to be bigger than pi, but still a 4 in the denominator. So that's 5 pi over 4. 315 is in quadrant 4, so it has to be bigger than 5 pi over 4, but still with a 4 in the denominator. So that's the 7 pi over 4. And let me move these guys around. Okay, so these are all the 30s because they're 30 away from their x-axis. So that means they all have pi over 6 in them. This is in quadrant 2, so that means I need an angle that's less than pi, but 6 in the denominator. So that's 5 pi/6. Now this is greater than pi, but 6 in the denominator. So that's just a little bit greater than pi, because pi is 6 pi over 6. And 330 is the largest of the angles, so there's my 11 pi over 6. Now over here in this column, these are all the 60-degree or pi over 3 angles. So again, I just need to pick them so that they are either less than or greater than pi. And you can see they're actually already in the correct order here. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So look for whatever patterns you can to help you figure it out. I think the pi over 3s are nice. They go up by 1 and then 2 and then 1. All of the pi over 4s go up by 2s. And then the pi over 6's go up by 5, and then 2, and then 5. So I don't know if that helps to kind of think of it like that, but this is something you can come back and look at if you have more time later on. Okay, so here is the reason that we learn this, and it's so that we can answer these questions related to sine and cosine on the unit circle. Okay, so what you do, instead of having to draw a triangle or even know like what 30, 60, 90 triangle this is you can just quickly look at your unit circle. And since it's sine, remember sine is the y value on the unit circle. So we're just going to come over to 11 pi over 6, which is kind of light on my screen here. I apologize. So here's 11 pi over 6. So we want the y value of 11 pi over 6, which is a negative a half. And that's it. That problem is done. Okay, then you have cosine now. Well, cosine is the x value. Oops, I meant to change the color there. So I'm going to go to 2 pi over 3 on my unit circle. So here it is. And I am going to use the x value there because we are talking about cosine. That actually happens to also be negative a half. Tangent is always the hardest one because you have to do a little bit of reducing or simplifying. So tangent is y over x. Okay, so I'm going to go to 3 pi over 4, which is here. And I'm going to take the y value, which is root 2 over 2. And the x value, which is negative root 2 over 2. And I'm going to just simplify that. Well, this one's not too bad because the x and the y are the same, so they just cancel. And you get negative 1 as your answer here. Now, your homework is to do a bunch of these practice problems. So hopefully you've filled in the unit circle completely. You are also welcome to Google it for now, but at some point in time, you will have to have at least part of it memorized. But we'll talk about that once we start reviewing. All right, hopefully that helped a little bit, and we'll talk soon.